Okay, so this is my third challenge that I've set. The first one was the most easiest, just trying to get you into the hang of using the program. The second one was a little bit harder. This one is even harder. And obviously, you can see I've got extra questions as well. So in total, I think I've got 7 questions. 1, 2, 3, 4, 5, 6, 7 questions. Some of them are slightly repeated of what you've been asked before, some of them a little bit harder. But anyway, let's go through them very quickly. So we've got polypentagon. So this one is similar to the star task that you were given in the previous one. However, you will need to increase the number of sides and repeat the shape a few times. So this one is one that may come up or something similar to this. We've got one small bug where they give you a program and you need to find the bug within that program. Again, that's another one that will possibly come up for something very similar to that. This one, drawing a PacMan. In the previous one, you were drawing it using shapes. This time, you're drawing it using the turtle, which I'll go over into a little bit more detail. Another one we have is taking an image and editing the image. We've got animal dice. So this one is a bigger one, probably one of the more difficult ones, where you will need to write a program to do some sort of calculation, take a bit of information in, and return some information at the end. Again, another maze one. This one is probably a little bit more trickier than some of the other ones that I've shown you. And again, another one, which is another maze one. Again, this is one of the more easier ones. So I'll try and start off with the easier ones in this video. We'll start off with this one. So to rob the robot, and that's rob as in the robot's name, not to rob the robot, but to rob the robot, a green square is treasure. So we've got Rob the robot here, and he finds that this is treasure. Rob can store quite long programs, so he can store very long programs, but only understands 3 instructions, which are move forward, turn left, and repeat 10 times. Write a program to get the Rob to the green square. Now, what we're going to do is obviously move forward a little bit, turn right, which we can't do, so we'll turn left 3 times. That is a common thing that they may ask you, and then move forward a few times and get to the green square. So quite easily, we're going to move forward. Let's put that in a repeat loop to save us some time. Looks like it's 1, 2, 3, 4. So we can try that out, test that out. We're going to turn left, and again, instead of doing that 3 times, let's just pop that into a repeat loop again. And then obviously we will move forward a few times again. Looks a bit more than 4. 1, 2, 3, 4, 5, 6, 7. So let's give that a go. So move forward 4 times, turn left 3 times, so turn right, and then move forward 7 times. And that should hopefully get us to the green square. Obviously, you can do a bit of trial and error, but there we go, an easy one, correct. Let's head over to the polypentagon one. Again, this one is fairly straightforward. So we're given a shape, which in this case is a pentagon. We want to draw this pentagon, but obviously we're going to increase the length and we're going to draw it quite a few times. So there's a few ways of doing this. We can actually use something called a function. A function is something that will run a few instructions, and that will be a bigger task which we can recall, a number of times. For example, when your parents ask you, or when someone asks you to make a bowl of cereal, they don't give you the step-by-step instructions. You know exactly what that function is. So another way we could do this is we can actually just put this in a repeat loop, more of a nested repeat loop, something that will take place. A nested repeat loop is something which is a repeat loop inside another repeat loop. So the way we can start this off is we can start off by drawing our pentagon. So I'm going to, it tells me that the first pentagon is on the side of 50 units. In fact, let's read the question. The polypentagon shown below is made with 15 pentagons. The first pentagon has a side length of 50 units. Each subsequent pentagon increases the side length by 5 units. Using the blocks provided, write a program that draws this pattern. So they've actually started us off in a good position. In some cases, they may have us facing in another direction. Maybe we start off somewhere else, but we're actually starting in a good place where we can easily increase the size as well. As this is increasing, I can actually change my length, my side length every time I've drawn that. and sort of code that each and every time. But in this case, I'm going to actually use a variable. So this variable I'm going to create, it will be my side length. I can call it length, side length. I'm actually going to call it SL for short. It doesn't really matter what you call it, as long as it's something that you understand. So let's set my side length to 50 to start off. So I've set my side length to 50, and now what I'm going to do is I'm going to draw my pentagon. So I'm obviously going to put that in a repeat loop. Pentagon has 5 sides, and then what I'm going to do is I'm going to move forward. Turtle, move forward. I'm actually going to move forward SL number of times. Okay, and that will do that 5 times, but obviously I want to rotate or turn every time I do that. A pentagon does actually will turn right once it gets forward there, will turn right 72 degrees. So again, turn right 72 degrees, and that should draw my pentagon. Now, once I've drawn that pentagon, what I can do is I can now increase. So let's head over to variables. I can change SL by 5. So that will now increase by 5. And then I can pop that into another loop, and I'll get that to repeat 15 times. Nope, 15, not 50. So what would happen now is I'll draw my first pentagon, change by 5, draw my second pentagon, third pentagon, etc. Let's run that. Okay, that looks like it seems to be working perfectly. And I can just speed that up. And there we go. That is correct. So next one small bug. So again, one of the types of questions that it may give you regularly could be one small bug in the program below has completely ruined the pattern. Press run to see the problem. All the numbers are correct. Something else is wrong. So it's not one of the numbers. They've given us a clue there. Can you fix this program? Fix the code to draw the required pattern. Now, obviously, we won't know what the problem is straight away. We will need to run it and see what the issue seems to be. So obviously, it seems like they are going through drawing around these gray shapes or these gray lines. But obviously, it seems to not be increasing in terms of length or thickness. So if I just run that again, it does actually look like it starts off really well, but then it sort of takes the turn that it shouldn't, or doesn't take the turn that it should. So let's stop that. Okay, so what we're going to do is by looking at that, we should be able to gather or get some information or have some understanding of what went wrong. So thickness to 4, seems like there wasn't a problem with the thickness to start off with. The length was 4. Didn't seem like there was a problem with the length to start off with. Didn't seem like there was a problem with the thickness. Repeat 82 times, said that there wasn't a problem with the numbers. Set width to thickness, again, the thickness seemed fine, or the width seemed fine to start off with. Move forward length, again, the length seemed fine to start off with. Turn right 36 degrees, again, it seemed to turn in the right direction. We know it's not a number, so it won't be that. Then we've got set length to length. So the length is increasing by 5% each time. And then set length to thickness. So that does look like the thing that stands out. So why would we set the length to the thickness times 1.05? Why are we sort of setting the length to the thickness plus 5%? That most likely should be thickness. So that's something which I've just sort of come across, and it seems to be a simple thing. They may not always be that obvious or that easy. Let's just speed that up. And as we can see, that's working. So something like that, just try to run through it. Try and think, does that look like it's wrong? It doesn't. Okay. You can always do a bit of trial and error and see if you get that correct. But yeah, you just need to try and understand exactly what's gone wrong there. Anyway, the next one. So Phoebe wanted to draw PacMan. She had a plan. Write a program that draws PacMan using any of the blocks provided. In this case, we're using the turtle. So the turtle will actually draw shapes, which we will code. It's a good way to start programming, especially using something like Python. But obviously, in this case, we've got block coding. Now, as we can see, again, like I mentioned previously, we are not facing in the direction we necessarily want. We can see that we've got our PacMan, a circle, if anyone knows, 360 degrees. 45 degrees we have there, 90 degrees, which is not shaded, and then we've got another 45 degrees there. Now, this is similar to the previous question that we had in the previous challenge that I set. However, that was drawing it using shapes. This one, we're actually coding, drawing individually. So we're actually going to go to my turtle. First thing I want to do is I can actually start drawing this, sort of take a jump and then carry on drawing this. But to make this a little bit easier for me, what I'm actually going to do, well, I'm going to set my color to the color I want first. I'm actually going to rotate 45 degrees, which they've given me here. So let's turn right 45 degrees. And now what I'm going to do is I'm actually going to move forward, which will draw a line for me. Move forward 20. I'm actually going to duplicate that because I'm going to move backwards 20. So I'm back to my start point. So I move forward, move back, and then I'm going to turn left 1 degree. So I'm just duplicating that. 1 degree, and I'm going to actually repeat that all the way around. So if I know that that was 90 degrees, 360 take away 90 is 270. So I'll actually get to that to repeat 270 times. And let's test that out. Okay, not quite. So I've obviously made an error somewhere. Error I can see actually that turn right 45 degrees. I didn't want that to be in the repeat loop. I wanted that to be outside the repeat loop. And obviously my circle is not, or my PacMan is not big enough. So let's change that move forward to something bigger. Let's run that again. Okay. Length is better, but not quite there. Let's see if the rest seems to be good. Yep, the rest of it seems to be perfect. So I'm just going to increase that further. Let's try and run that again. Let's speed that up. And there we go. That is done. So let's move on. Correct. There we go. How red? So the pixels in the images below are defined by 3 values: red, green, blue, 0 to 255. So as I've mentioned before, an image is made up of pixels, which you can consider as tiny little squares, like a square grid. Each square, each pixel has its own individual color. In this case, anyway, that's how they're made up, and each has its own individual color. Each color is made up of either a red, green, or blue value, and that's in this situation, not for all images. And each red, green, and blue would have a value between 0 and 255. If it's closer to 0, there's less of that color in there. Closer to 255, there's more of that color in there. If they're all 0, it will be black. If it's all 255, it will be white. If it's red is 255 and green and blue are 0, it will be a thick red. Anyway, the second image, which is this one here, beautiful image, is made from the first by setting the pixel values of all pixels, where the red value is the highest of the 3 values, to 25500, so that's fully red. Setting the pixel values of all pixels where the green value is the highest to green. Setting the pixel values of all pixels where the blue value is the highest of the 3 values to blue. So basically it will see if there's more red than any of the others, it will set it to red. Same for green, same for blue. Setting the pixel values of all pixels where the red, green, and blue values are equal to 0, so to set it black. So write a program that transforms the first image into the second one. So as I've mentioned before, what we will be doing is we will be going through each and every pixel. So we're going to head down to image for P in pixels, so that will go through each and every pixel. I'm going to use one of these, an if statement. You've got these little cogs there in this if statement. So if you did want to have an else if, you can do. And in this case, I will. So I'm going to say if this is met, we do this. Otherwise, we're going to check if this other condition is met. And we are going to use them 4 times because we have 4 conditions. So my first one is going to be that if, and remember, we always need to use one of these logic things with an operator. So we've got if it's equal to, not equal to, less than or equal to, greater than or equal to. And in this case, I'm going to say if my red value So get my red value is greater than, let's see if I can zoom in a little bit. There we go. Is greater than my green value. And I'm actually going to use an AND here. And I'm going to pop that in one side of the AND. I'm going to duplicate that, pop that in the other side. Again, let's zoom out a little bit more. So if my red value is greater than green and my red value is greater than my blue, then I'm going to set my R value to 255. Let's duplicate that 3 times. Let's set green and blue to 0 and 0. So if I run that, okay, as you can see, it has found all of them, which red is highest, and it has turned them red. So now I know that works. What I'm going to do is I'm going to duplicate this. Let's pop that there. Let's duplicate that again. Let's pop that there. Let's duplicate. Unfortunately, we can't duplicate the 3 together. Or can we? Duplicate. And in this case, the green is going to be 255. And in the third case, the blue is going to be 255. Okay, so let's test that out. Oh, okay, yep, I forgot to change my if statements. So if my green value is greater than my blue and my red, and if my blue value is greater than my green and my red. So again, nothing wrong with getting it wrong the first time, as long as you can pick up where you've gone wrong. There we go. So far, so good. Now, if the pixel values of all pixels where red, green, and blue values are equal to 0, are equal, set them to 0, 0, 0. So now what I can do is I can actually duplicate these again because I want to set them to 0. In this case, I want to say that if my red value is equal to green and equal to blue, then they should be set to black. So let's run that. That looks like it's good, correct, well done. So let's move on. Okay, now this one here is quite tricky. So animal dice have pictures of 6 different animals, 1 on each side. 2 identical animal dice are rolled at the same time. The person who rolls the most legs goes first. So we roll the 2 dice. Whoever gets the most legs, they go first. Centipede and spider are shown after rolling. The number of legs is therefore 100 plus 8, so 108. The animals, we've got a set of animals, so we will need to create a database or a small database, something to have all of this information in. Your task is to complete the function provided so that you create a program that inputs 2 of the animal names. They can be the same animal and outputs the total number of legs. Do not alter any of the blocks provided. So if we can see here, they've actually started us off with a couple of functions. So we talked about functions earlier on. So we've got how many legs with animal 1 and animal 2. So that will actually take in animal 1 and animal 2 and return some information from how many legs. So that's an actual function. And what we're inputting in this case is animal 1 is equal to centipede, animal 2 is equal to spider. So I'm going to actually start off by creating another function. Let's scroll down a bit, functions, and what I'm going to do here is my function wants to return something, so I'm actually going to do that, and I'm going to call this legs on die, so this will tell me how many legs are on each dice or die. And I'm actually going to have an input name in this one, So I'm actually going to input animal. There we go. So let's try that again. Input animal. Okay, so I've popped that in. So I'm actually going to have animal being inputted. And I'm actually going to say in this case that if, so again, I'm going to head down to logic. If, and I've got 6 on the die, so I'm actually going to have 6 of these. So 1, 2, 3, 4, 5, 6. Okay, let's get rid of that. And I'm actually going to say that if my animal, again, let's head over to my logic. If my animal is equal to a certain bit of text, so we're actually starting off with ant and 6 legs, then so I'm actually going to create another variable and I'm going to call this legs. And I'm going to return legs at the end. I'm going to set legs to the number, and ant is 6. So I'm actually going to duplicate 1, 2, 3, 4, 5, 6. Let's pop these in, get them out of the way. Let's duplicate my set legs. 1, 2, 3, 4, 5, 6. Okay, so now I've got this, I can just change them all. So now what I've got is cat 4. So cat is equal to 4 legs. I have centipede is 100 legs. And I have flamingo is 2. Flamingo is 2. Snake is 0. And spider was 8 legs. Okay, so now what I've got is I've got a function legs on die with animal. So we take the animal, and depending on what we get, we then set legs to whatever number we have, and we return whatever we have as legs at the end. Okay, now what I'm going to do is, now I've got how many legs? I've got animal 1 and animal 2. So what I'm now going to do is I'm going to grab a variable. I'm actually going to set my total legs to legs on die. So let's grab that. So legs on die with animal 1. And let's duplicate that because we're going to use that again. And now I'm going to change my legs, total legs, to animal 2. So now what I've got is so once I execute this, let's just go through this. How many legs with animal 1 and animal 2? Animal 1 in this case is centipede, animal 2 is spider. So I'm actually executing how many legs. And with this, I'm actually setting my total legs to legs on die with animal 1. So now I'm going to go to legs on die. I'm going to see I've got animal 1, which is centipede. I'm going to go to centipede. I'm going to set legs to 100. So I'll return legs to 100. And that's what I have there. So 100 goes into that. Do the same here. So where I run animal 2 with spider, I'm going to change my total legs by spider, which in this case is 8. So I'm going to get 108. So when I run that, it's brought up 108, and that should be correct. There we go, correct. And one last one to go. So write a program that takes a robotic turtle from the red start square to the green end square. Now I can actually see that this is the same as this, and this is a little bit different. I'm not sure if they're the same. But anyway, so let's start off by moving forward. Let's put that, we don't need to put that in a loop. Moving forward, and then we're going to turn right. Turn right, let's move forward, 1, 2. So movement, move forward, move forward. Once we're there, we're going to turn right again. Move forward again, turn left. Move forward, move forward. There we go. So now at this stage, we should be here. And now what we can do is we can actually turn left. And now we're going to use a repeat loop. And in fact, these do look quite similar in terms of I'm not sure if that's repeated. 1, 2, 1, 2. Okay, and then I've got something there. Anyway, let's very quickly get a loop, and inside that we're going to have move forward 1, 2, 1, 2. In fact, we're going to repeat this twice. This might get quite long. So it's all about just recognizing a pattern. Before 1, 2, turn left. This is a bit tricky because it's I'm looking the other way as well. Turn left, move forward, turn right, move forward, move forward. Turn left, move forward, turn right. And if I run that twice, hopefully that should, okay, so I had a little bit of a glitch there. So move forward, turn left, move forward, turn right, move forward, move forward. So as a, okay, that should have been turn right. Turn right, move forward, turn left. Hopefully that works this time. There we go. And now I'm there. I can move forward 1, 2. So that's obviously going to be outside that loop. Move forward, turn left. And I can actually pop that inside another repeat loop. Let's repeat that 1, 2, 3 times. Okay, it's just about recognizing patterns. And then obviously I can move forward twice. Move forward, turn left, move forward, turn right. Move forward. Turn right. And move forward. So hopefully I actually got that right this time. So again, recognizing the pattern. Again, instead of having that within a nested repeat loop, I could have actually had that in a function or more than one function. In fact, let's see where some of them still not move forward, turn right, move forward, turn, no, it's quite different. So there we go. So I hope that helped. Please do give them a practice. I will put a link to this one in the comment section or in the description. I will have a couple more tests or quizzes, challenges coming out, so please do check them out. And obviously the OUCC is coming up very soon, so I hope you guys all do well in that.